Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 14D assignment. Okay, first one, number one, for which of these probability experiments does the binomial distribution apply? Explain your answers. So, there's two things that need to happen for a binomial distribution to work. There has to be two possible outcomes, and each experiment is independent, meaning that the probability for each experiment is always going to be the exact same. Okay, so a coin is thrown 100 times. The variable is the number of heads. So each time you flip the coin, you're going to get two possible outcomes, heads or tails, and then the probability each time is the same. So it fits the two rules. So it does apply. So I'm just going to put yes on that one. C, a box contains 5 blue and 3 red marbles. I draw out 5 marbles one at a time, replacing the marble before the next is drawn. The variable is the number of red marbles drawn. There's two possible outcomes, red or blue, and the probability is the same for each experiment. So this one also works. Okay. And then E, a large bin contains 10,000 bolts, 1% of which are faulty. I draw a sample of 10 bolts from the bin. The variable is the number of faulty bolts. So it's either you get two possible outcomes, either faulty or not faulty. The one problem with this is that you're drawing out a sample of 10 bolts, so you're taking out 10 at a time. So really that changes the probability each time because it's not a repetition of independent trials. Okay, because you're taking 10 out at a time, you're not replacing. If you were to take one at a time and replace it, and one at a time replace it, then that would be independent trials, and then it would work. But this one, it would be no. Okay, number 3, if a coin is tossed 4 times, what's the probability of getting 4 heads? So, really, the probability of getting the 4 heads, we could use our Pascal's triangle, right? So we had to do that on number 2, so I'm just going to draw that in here really quick. So there's row 1 is 1, 1. There's a 0 here. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 0 is 1. All these down the diagonal are always 1, and we want 4. So there's 1, 2, 3. This will be the 4th one. Oops. This is kind of a sideways one. Okay, 1 plus 2 is 3. 2 plus 1 is 3. And 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And that's going to be 1 there. Okay, so this is our 4th row that we're looking at here. Okay, so 4 heads. Okay, so that is 0 heads. If we're going to assume that heads is the desired outcome, 0 heads, 1 head, 2 head, 3 head, 4 heads. There's one way of getting that to happen. Okay, so we'll do 1 times the probability of getting heads each time is 1/2, and we want that to happen 4 times. So that's going to equal, we're going to just do 0.5 to the 4th power. All times 1 isn't going to change anything, so it's 0.0625. 0.625. So 6.25%. Okay, for C, what's the probability of 2 heads happening? So that's 0 heads, 1, 2. So it's going to be 6 times the probability of getting the heads is 1/2, and there's 2 of those. Probability of getting tails is also 1/2, and there's going to be 2 of those. Okay, so we can simply put this all into our calculator. 6 times 0.5 to the second. Go over times 0.5 also to the second. We could have just done 0.5 to the 4th. That would have given us the same thing. And that gives us 0.375, which is also 3/8. Okay? Okay. 5, a box of chocolates contains strawberry creams and almond centers in the ratio of 2 to 1. So strawberry cream is one type, and almond centers is another type. So there's a ratio of 2 to 1 for the strawberry creams to. So for every 2 strawberry creams, there's 1 almond center. Okay. 4 chocolates are selected at random with replacement. Okay. So basically, you pick one out, look at it, see what it is, put it back in, pick another one out, put it back in, so forth and so on. Okay. So let's see, 4 chocolates. I'm going to bring the Pascal's triangle over from our last problem here. Okay, here's our Pascal's triangle. We want this because this is our 4th row. And let's just like say that the expected outcome is the strawberry creams, so, or like the desired outcome. So all strawberry creams. So that's 0, 1, 2, 3, 4. There's one way to get all strawberry creams. Now, again, the ratio is 2 to 1. So let's say if there's a bag, it's going to have, to make it really simple for us, we'll have 2 strawberry creams and 1 almond center, right? So the probability of picking a strawberry cream is 2/3, and that is all 4 of them, right? So that's going to just be 1 times 2/3 to the 4th power. So we can just do this, 2/3 to the 4th power gives us 0.1975. And also, hopefully this will work out, but you can do math, enter, and it'll also give it to you as a fraction as well. Okay. I prefer the decimal. The back of the book is going to give you probably the fraction answer. See here. So you can write either one. Equals 0.1975 or 16/81st, I think is what we came up with. Yes. Okay. So either one of those for A. For B, what's the probability of getting 2 of each type? So that's 1 strawberry cream. That's 0 strawberry creams, 1, 2. So there's going to be 6 times 2 strawberry creams. The probability of getting a strawberry cream is 2/3, and we want 2 of those. And then we also multiply by the probability of getting an almond center, and there's 1 out of 3 probability chance for those, and there's 2 of those as well. Okay, so we just multiply those out. 6 times 2/3 squared times 1/3 squared. Oops, that does not look right. Let's get this out of there. 1/3. Close the print. This. Oh, let's get this fixed. Delete. There we go. Squared. Okay, good. All right, get that, and it gives us 0.296. Oops. So 29.6%. Or again, we should be able to turn this into a decimal by math. Enter. And a lot of your scientific calculators will also do the same thing. 8/27. Either one of those is just fine. Okay. And then for part C, 2 of each. At least 2 strawberry creams. So this is where it gets a little interesting. This is where we got to do. So this is 0, 1. We got to do this plus this plus this. Okay. So we got to do probability of 2 strawberry creams, 3 strawberry creams, or 4 strawberry creams. So we already did this one. 6 times 2/3 squared times 1/3 squared. This is for getting exactly 2 strawberry creams. And then, let's see, that's going to equal, we already know that that's going to equal, let's do our fraction here, 8/27, not 6. Okay, and then we're going to have to add 4. And now we're getting 3 strawberry creams, so that's 2/3 to the 3rd times 1/3 to the 1st. And that'll give us a number. And then we also have to add in the probability of getting all strawberry creams, so that's 1 times 2/3 to the fourth, which we actually already did up here as well, times 1/3. There's none of those, so that just turns into 1. And that was 16. 16 over 81. And then we just got to figure out what this one is, add those all together, and away we go. All right, so let's do this. 4 times 2/3 to the third times 1/3 to the first, or just times 1/3, and that gives us 0.395, and we can do math, enter, enter, and that's 32 out of 81. Right, so then we can just add these all up. 32 out of 81 plus 8 out of 27 plus 16 out of 81 gives us 0.8899, 0.8888. Math, enter, enter is going to give us 8/9. So that gives us 8/9, or 0.889, either one. Okay? All right, one more to take a look at. Number 6. In New Zealand in 1946, there were 2 different coins of value 1 florin. These were normal kiwis and flatback kiwis in the ratio 3-1. From a very large batch of 1946 florins, 6 were selected at random with replacement. Find the probability that blah, 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 blah. So this is at a ratio of 3-1. This is the normal kiwis, and this is the flat kiwi, right? So 6 were selected. So now we got to do our we have to do our Pascal's triangle with 6 rows. So I'm just going to write that out really quick. I'm just going to show you really quick how fast we can do this. Remember all of these down the diagonal. Row 1, 2, 3, 4, 5, 6. Same thing here. All these down the diagonals are all going to be 1s here. And then we add those 2 together. That's 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5. 1 plus 5 is 6. And then 2 plus 1 is also 3. This is going to be 4, 5, and 6. 3 plus 3 is 6. 4 plus 6 is 10. 6 plus 4 is also 10. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. And there's our Pascal's triangle. Okay? So, again, this is the row here that we're going to be interested in. Find the probability that 2 were flatbacks. So it really doesn't matter which way you look at this, if it's like the normal kiwis versus the flatback kiwis, which one is the success or not. So let's do this. Since they're talking about flatbacks on both of these, we'll consider getting a flatback as our desired outcome or whatever. So this is 0 flatbacks, 1 flatback, 2 flatbacks. So that's going to be for A. We got 15 times the probability of getting a flatback. Again, we've got in a bag here, we've got 3 normals and 1 flatback, right? So that's 1 out of the 4 are flatbacks, and that's going to be, we want 2 of those. So, and you're drawing 6 total, so that means the other 4 are going to be the normal ones, so that's 3/4. Okay, so now we can just pop this up here. 15 times 1/4 to the second times 3/4 to the fourth. And that gives us 0.297. So 29.7% of the time. And if we do math, enter, enter, it also gives us, hopefully it gives us a crazy, awful fraction. But I'm just going to tell you right now, I'm looking at the answer in the back of the book, and this is the correct answer. So you can leave it like that. I like this one a lot better. but that one's correct. And then for part B, at least 3 were flat backs. So we've got 0, 1, 2, at least 3. So it's going to have to be this one plus this one plus this one plus this one. So we've got 20, 15, 6, and 1. So this is going to be, this one here is going to be for 3 flat backs, 4, 5, and 6. And actually in the next section that we go over, I'm going to show you ways of doing this a little bit easier with your graphing calculator. But we'll do this the long way here, and it's okay. So this is 3 successes. So a success would be 1/4 to the third. There's 6 total. So these exponents here always have to add up to the total number of trials that you're running here. So 3/4 to the third. Okay, and then we've got 15. This is going to be 4 desired outcomes. So 1/4 to the 4. And that means the other 2 are going to be 3/4. And then this can be 5. So 1/4 to the 5th times 3/4 to the 1st. And this is going to be all 6. So that's 1/4 to the 6th power times 3/4 to the 0 power, which just turns that into 1 there. Okay, and then now we're going to want to calculate these all out. Okay, here's all of our probabilities for each of those calculated out, and this one has got such a small probability, it's less than 0.1%. It's like 0.02% chance. So if we rounded it to the 3 decimal places, then we would just add these up and away we go. And that's 9, that's a 6, and that's a 0. So 0.169. So 16.9% of the time you're going to get at least 3 flatbacks. Okay? And if we were to have done this with the fractions, we would have got 347 over 2048, which, look, is 16.9%, 0.169 there as well. Okay? Okay, that's all we have for the 14D assignment. If you have any further questions on this or anything else, please feel free to ask. Thanks.